Hello everyone, welcome to the channel. We have a polynomial equation today to be solved for x. We have x to the fifth power minus 1 is equal to x minus 1 to the fifth power. I will present two different methods. The first one is factoring this left hand side as x minus 1 times x to the fourth power plus x cubed plus x squared plus x plus 1, and this is equal to x minus 1 raised to the fifth power. Since we have x minus 1, both sides we will cancel, but before cancelling we will find our root. X minus 1 equals 0 gives x is equal to 1. This is our first root now. Then we can cancel this side and we can drop this power to fourth power. Now let's continue with x to the fourth power plus x cubed plus x squared plus x plus 1. This is equal to x minus 1 raised to the fourth power. Now we can expand right hand side as our binomial theorem. It is x to the fourth power minus 4 times x cubed plus 6 times x squared minus 4x and plus 1, and this is equal to the left hand side again, x to the 4, x to 3, x squared plus x plus 1. Now we can cancel this x to the fourth power now, and we can cancel this constant term plus 1s. So we will have 5 times x cubed plus minus 5 times, sorry, this is minus 5 times x squared and plus 5 times x. This is equal to 0 now. We can factor 5 and one of x's and write 5x times x squared minus x and plus 1. This is equal to 0 now. This is easy since we have found one of our roots from this x. We have x is equal to 0, another root, and we have a quadratic now. X squared minus x minus 1 can be solved by quadratic formula. That is, x is equal to negative 1 becomes plus 1, and plus minus the square root of negative 1 squared is 1, minus 4 times 1 times 1 becomes minus 4, and divided by 2 times 1. This is also equal to 1 plus minus root negative 3 divided by 2, or 1 plus minus root 3 times I divided by 2. So we have two complex roots and 0 and 1 as our real roots. This is the first method and it is easy to solve actually. Let me show you another one. The second method is we have x to the fifth power minus 1 is equal to x minus 1 raised to the fifth power. We can expand this right hand side directly. We can use binomial theorem to write x to the fifth power minus 5 times x to the fourth power plus 10 times x cubed minus 10 times x squared plus 5 times x and minus 1. And we have x to the fifth power minus 1 left hand side. We can cancel x to the fifth power and we can cancel negative 1. We will have 0 equals negative 5 times x to the fourth power plus 10 times x cubed minus 10 times x squared and plus 5 times x. Multiplying by a negative, we will have 5 times x to the fourth power, 5 times x to the fourth power minus 10 times x cubed, I guess, plus 10 times x squared and minus 5 times x. This is equal to 0 now. Now factoring our 5 times x, we will have x cubed minus 2 times x squared plus 2 times x and minus 1. This is equal to 0 now. Then we have x is equal to 0, the first root we reached in this method, and we have a cubic. We have a cubic now, x cubed minus 2 times x squared plus 2 times x minus 1. This can be solved by factoring like this. We have x cubed minus 1 minus 2 times x squared plus 2 times x. This is equal to 0. Now x cubed minus 1 can be factored into x minus 1 times x squared plus x plus 1, and the second part here we can factor a minus 2x. We will have x minus 1 again, and this is equal to 0 now. We are almost done. We have a common factor. We have x minus 1 as a common factor. Then we have x squared plus x plus 1 minus the other 2x. Now this is equal to 0. So the other real root here is x is equal to 1. And we have this quadratic x squared minus x plus 1 is equal to 0. And as we found before, the roots here are complex, 1 plus minus root 3 times I divided by 2. This is the second method. You can prefer the one you like. Thank you for watching and see you in the next videos.